to begin the walkthrough, we're going to open ProCAM and we're going to load all the files that we need shown here on the left. So there's 4 browse buttons. We'll start at the top. So this tells you we want to load the top copper here. So I'm going to browse actually to, for this walkthrough, we're going to use the samples that were included in the installation folder. So I'm going to C, program files x86, then the Zippy Robotics folder, and then you'll see sample gerbers here. So these are what the files that we're going to use for the purposes of this walkthrough. So I'm going to grab the .gtl file as the top layer. These files were made in KiCad. So I'm going to open that. In about 3 seconds or so, it should show you the imported file, and there it is. And we'll go here to get the bottom copper, which will be this one, GBL. And once that's done, we'll click on Browse for the drill file, which is right here, .drl. And that one's fast. You can see that it already has there are gray circles with yellow outlines. And you could zoom in too. If you scroll up or down, you can zoom in. And then we want the cutout file, which is the .gm1. These extensions can change. It's not really important. Every package is going to export a different way. As long as you know what's top, bottom, the drill file and the cutout file is fine. So those are our 4 files. We can also, if you want to get a look at the bottom, we can, let's say you want to click that off. So you got these eyeball icons here. So these eyelids, you can click them on and off, turn off different layers or turn them on. So I'm going to turn the rest of them back on. Actually, maybe I'll hide the bottom for now just so I could show you. So the next step is to go to the Operations tab, and you'll see that this is where we're going to select what bit we're going to use. So if we zoom in, the idea here is that we want the bit to be small enough that it could fit in between the smallest gaps in our design. So typically, this is a surface mount design. So typically the 5 mil diameter, which is 0.005 inches, 5/1000 of an inch, that one's going to be able to do the majority of what you need. And you can see that it goes through. This is what you would want to check, that the green lines, which are our tool path, you want to make sure that they go everywhere that they need to go. And just as an example, if I change this to, let's say, 10 mil, then you'll see that actually it does go through a lot, but here, see, it doesn't. So those would be too large. Or just to make the point even more clear, let's do almost 20 mil. Click on that one. So here, it can't fit between any of these pins, so it doesn't go there. So this is not going to isolate all of the pads that we need isolated. So we're going to go to this one, and this is the number of contours that you're going to do. So right now, this is the way that ProCAM works. You have to give it the number of contours that you want to use. But typically, keep the number kind of low, both for time and also because if you do high ones, it might work okay. Like this board is fine, but I've noticed some issues with that. We're going to improve that with future releases. But for now, just for this design, I would say 3 should be good. It'll give you a little more room to solder. So, but what I was going to say is that for future releases of ProCAM, I'm going to have a button in here or a checkbox that will let you, if you tick it off, it'll say complete copper removal or copper rub out. So the vision is that you'll have one selection box for your fine bit, which in this case we would choose this one, and then another box where you would choose a secondary bit, which would do all the coarse work. So like all this stuff in here, there's no reason to use a 5 mil end mill to do that. You're just wearing away a more expensive bit, and it'll be a slower process. Instead, we would let you use something like 0.063 or 0.0938, which you can see are very big bits, and they'd be a lot faster. They'd make quick work of the copper floating islands that are here. But for now, it has to work in this contour mode. So 3 there, and then for the bottom, I'm going to click this off and turn on the bottom copper just to get a more clear view. And we're going to select, again, 5 mil will work well, and I'll do another 3 contours. And then we can click continue, and that will then take us to the control panel and the preview page. So now this is what the board's actually going to look like when it's routed out. So you could see how much of it gets isolated and how much copper is going to remain. And this should be okay. So I'll zoom out a little bit. Oops. I'm doing this on a laptop with a touchpad, which is not ideal because I do like the scroll wheel. All right, so we're over here. And actually, I'm going to close this because I figure I have all this space. I might as well drag. You can drag your Gerber file. So if I left click on this, you'll see when you move into the artwork, you get this hand icon. Instead of the mouse, you get the hand. You can left click and you can drag this where you want. So I might as well just put it in the middle. Like so. Now I'll hit continue. And there's our preview. Oops. And now we can follow the instructions on the right. So what we need to do is make sure the board is secure and over the sacrificial layer. So I'm going to check that off because we already did that. But if you didn't, this is the time to do so. Use the double-sided tape, make sure the sacrificial layer is there, press it down, and then install a 0.005 inch 15-degree end mill, and that's because that's what we selected in the prior step. So it'll tell you to use whatever bit you use to generate the toolpath. So I'm going to do that now. Actually, I'll put the video here so you can see. So here's the 5 mil end mill. Thread it through the bearing carefully. And my spindle motor plate is already disengaged, so now this is free to enter the spindle. So we'll go straight up, and then we rotate it 90 degrees so that it grabs it. And if I pull down, I'll see that it pulls it back up because it's spring-loaded. And by the way, you could also use this retract spindle button. So this will just take it up in one shot. So if I click that, it's going to retract the spindle all the way to the maximum amount to give you the most room here to work with. So I'm going to show inserting the bit from this angle because it might be a little bit better. So I have my bit clamp with the bit inserted, the same size that the software is asking me for. And now it's going to go right in the spindle bearing, and then you rotate it 90 degrees and it'll snap in place, and I'll give it a little pull down just to test it, and it pulls it back up. And now I'll engage the spindle motor, and I'm also going to pull up and rotate counterclockwise like so. So now it'll stay engaged, and we can test also that if I rotate the spindle motor, we see that the bit rotates. So now here I can check that off, and now check that you're wearing safety glasses and hearing protection, and we're going to probe. So you click the probe button, and you can see that it says place an alligator clip between the board and brass bar, ensuring electrical contact. Only afterwards should you click continue. So we're going to take our alligator clip wire, and we're going to clip one on the board, and the other end is going to go on this brass bar. And I'm not going to go too deep into it. I'm going to keep it towards the edge because I want to make sure that it's not going to collide with the bit that's going to come down. So instead of making it all the way in here, I'm going to go here. And kind of the same applies for this one. Instead of making it too far in, all I need is to clip a little bit. So I'm going to put it right there. And then once we do that, we can click continue. Because as soon as we click continue, it's going to start moving now. Now it's just going to probe the board. once that's done, we can remove the wire because we won't need it until we probe the bottom. And we can now click mill top, but before we do, we're going to apply some mineral oil. Just right in the middle, because that's where we're going to be milling. Because we dragged our gerber file to the middle of the board. So put a little bit there. And you could also use the brush that's included to spread it around a bit. But we do want it to be a puddle. We don't want it to be too thin. Because what's going to happen is all of the chips, the dust from the FR4, and the copper chips, they're going to stay suspended in the oil. So it's an easy way to keep things out of the air, because you don't want to breathe this stuff. And then you could just wipe it off with a paper towel afterwards. So now that we did that, I'm going to click mill top. So now the top is done milling, because we see, aside from the fact that the machine is finished and it brought forward the board, we see a green check mark here. And I'm going to wipe away all these chips so we could see how it performed. And you could see all the copper that's on the paper towel there. So now we can click the right arrow, and this will take us to the next step, which is to drill. So now that we're at the drill panel, we're going to check this off because that didn't change. The board is still secured over a sacrificial layer. And we're going to make sure we're wearing safety glasses, hearing protection. And now we will click drill. And it's going to tell you now with this prompt what you need to insert. So it's going to start with 0.8 millimeters. So we're going to insert a bit of that size, a drill bit. First, we have to remove the bit that's in there, which is the 5 mil 15 degree bit. So I'm going to do that now. So we're going to rotate clockwise, disengage the motor, rotate the bit 90 degrees, and now we're going to go straight down. And in this case, it took the bearing on the bit, so that's fine. We're going to remove the bit. And here's the bearing on the bit. We're going to take that off. And we're going to put that back in the bit clamp. Then we're going to put our bit away. So we're going to put this drill bit in now. You go straight up, making sure the plate is still disengaged. Rotate 90 degrees so it locks. And then engage the motor and turn the plunger clockwise. Lift it up and turn it clockwise. And now it's free to engage the spindle. Or engage the bit, rather. I'm going to do a little test to make sure everything's good. I rotate the spindle motor, I see the drill bit rotate. So now that that's in there, we can click continue. And the machine will start moving. Now that we've finished drilling, we're going to click the right arrow again, and that will take us to the bottom layer steps. So here now we're going to pry the board up and flip it over back onto the sacrificial layer. We're going to take our screwdriver, and in this case, you know, I could pry from here, but then that's going to rip up the sacrificial layer, and then we got to stick it down again. So I'm going to see if I can get it on the edge of the corner of the board. And be careful, because when it releases, your hand is going to slip, so you don't want to be underneath this area here with all the metal parts. Okay. So I'm going to take this tape off. We could throw it away. And there's the bottom side of our board. Here is the top. Now I'm just going to get the rest of the tape off of the sacrificial layer. And that's done. And now we're going to put the bottom side down, just making sure this is still good, and it is. So when we flip this, this is how we milled it in this direction. When we do the bottom side, we just want to flip it like a book. So it's like you're turning the page, and we'll stick that down. So I'm going to grab the double-sided tape, and again we're going to do 4 pieces. Okay, so now that I have the 4 pieces of tape, we're going to stick it down. Make sure I'm flipping it the right way. And it's not super critical how you orient it, because it's going to correct for that. Any rotation you impart, or translation left to right, up and down, rotating it, ProCAM will be able to correct for that. The way it does that is by selecting 2 of these drilled holes as fiducials, and you're going to see that in the next steps. Now, before we do anything else, we want to click the hole select mode, because we need to know how we flipped the board over exactly. Like, where is it exactly on the milling table? So we have to do this. And this really should be considered a bug, that these are not grayed out the way locate holes is. In the beta version that's upcoming, I'm going to make sure that those, until you do this, you won't be able to do that. If you click probe now, it's not going to work. You should restart. You should restart ProCAM. So let's click here, hole select mode. And now it tells you choose 2 holes, then exit hole select mode. So we enter and exit by clicking here. So now we entered it. We're going to click any 2 holes that you want, because we need 2 holes for the purpose of figuring out how the board has rotated or has been translated on the table. So it doesn't really matter. You could look at your board and see which ones are, I mean, if there were different size holes, you can choose the smaller ones, because we're going to do what we did with the calibrate card. Basically, we're going to move the bit over the hole. If the hole is a huge hole, then it's going to be tough to say where it's centered. In this case, all the holes are small and they're all the same size, so it doesn't really matter. I'll just take maybe the leftmost one and the rightmost one. And if you want to change your mind, you can right click and it'll let you choose a different hole. You can't choose more than two, so I'll just choose these two here. Okay, so now once I chose my two holes, I can exit hole select mode, clicking here. And now we have to locate those holes. So locating meaning using the physical tool to measure where they are on the milling table. So click locate holes. And now we don't know where the machine is, so we're going to click go home first. That's the first step here. And the machine is going to move home. Okay, and so right now I inserted the 5 mil 15 degree end mill because that's what we're going to be using for milling, and it's also a fine tip, so it'll do well for locating the holes. But I'm going to do the same thing that we did with the calibrate card, and that is I'm going to remove the bit clamp, but I'm going to engage the motor. This way the bit will still stay in the clamp, so I'm going to do that now. I'll take that out. I'll also take out the bearing because I don't want that falling out. I don't want to lose it. Okay. So that's there. And I already went home, so that's fine. And now we can click highlight hole 1. So we're going to click that. And now you can see that hole 1 is spinning and growing. So that's the hole that we highlighted. So now that we know which one we're going after, we can move the machine there. So we're going to say, go to approximate hole 1 location. Now the machine is going to move roughly over that hole. And it's a very rough move, so I'm going to move it down a bit. Okay, so I'm too far to the left, so I'm going to go to the right. I have to move up some. Now I'm going to disengage the motor so we can drop the bit down a bit. And I'm pretty close, but it's not centered. So looks like it has to go slightly to the right and slightly down. Let's see how that is. A little bit more. So right now the bit is in the hole, but it's not centered in the hole. You do want to be careful, because if you hit the wrong button and you do a fast move while the bit's in the hole, then you're going to break it. And that looks like it's exactly where I want it to be. So we're going to now click set. And as you can see, just like before with calibrate, it's going to take those coordinates and put them there. So now that we got one hole done, I'm going to move the bit up. So now we want to make sure the bit's all the way in, and it is. It's engaged, the motor's engaged. So we're just going to move the tool up in Z, because the next step is to move to the second hole. So we're going to move it up. And now we're going to go highlight hole 2. Now you can see it shows the next hole. And so it's pretty much just to the right and slightly up. So I'm going to hit the right button. And we're going to go all the way to the upper right hole. In this case, I'm not going home. I'm not going to approximate hole to location because that's going to send the machine home or the head home, and then it's going to move to where it thinks approximately hole 2 is. But in this case, the holes are pretty close together, so I'm just going to directly go to it from hole 1. That's why I just went straight to this button. And I'm moving it up a bit. Okay, so I'm going to accept that. So now over here, we're going to click Set for hole 2. So now that we have both of these XY coordinates set, we can close this window. And now we can probe and mill. So the first step, though, is to probe. And don't forget, we want to put the spindle back up. So we're going to hit retract spindle so that we can put the big clamp back in there. So right now, the bit isn't being retained by the big clamp. It's just held by the motor plate. See that everything's good, and it is. And so now we can probe. We get the same pop-up. So this reminds us that we need to connect the alligator clip. So I'm going to do that the same way that I did before. So here's one on the board. I'm going to clip that here to the end of the probing bar. Okay, so now we can click continue. And now that that's done, we can put some mineral oil down, and then we'll be able to mill the bottom. So I'll just grab the mineral oil. And since this is a small board, which we can see from the preview, we can kind of gauge where the extents of the boundaries are. We can just pour some. Looks like right about here should cover everything. Okay. And now I will click mill bottom. So the machine's going to go home first, touch off on the probe bar, and then it's going to mill out the board. Now that we're done, we're going to do the next step, which is cutting out or routing out the board. Okay, so this is the router bit here. In this case, it has an orange depth ring, and it has printed on here the diameter. So all of our router bits are the same size. The software assumes that it's going to get a 0.0315 inch router bit. So this is what's going to actually go through the board and cut out the panel. And once again, we do it the same way. We thread this through the bearing. This is the bit clamp. We take our bit and we just thread it through the bearing, being careful not to bump into the plastic housing or the bearing itself. And then we see that the motor plate is disengaged. We find the spindle bearing, go straight up, rotate 90 degrees. You hear the magnet click, and then we can engage the motor. And so this is now ready. So back to the software, the board is still secure, and it's on top of the sacrificial layer. We installed the bit, and we're going to wear safety goggles and hearing protection. And now we're just going to put a little bit of mineral oil down, and then because this is a dusty operation, for this we want to have a vacuum also that's on, sucking away all the dust that's generated. So we're going to click cut edge now. And before it starts, I do want to put mineral oil. Okay. So now I'm going to take a paper towel again, and I'm just going to clean all this dust off of it. And now, very easily, we should be able to lift up the board. So I'm going to take that screwdriver again. And I'll just go right here. And as you can see, it'll come right up. There's some double-sided tape in there, so you have to, I mean, if you can't get it up, you could take the whole board off. But this was loose enough that I can grab it. And there we go.